Hello friends. So this video is going to be on how to solve logarithmic equations. So if we look up here, it says that continuous logarithm uses log properties. And then what is most important to us is this statement right here that says use the one-to-one property, which is if log base b m is equal to log base b n, then the rule is very simple. The rule is m is equal to n. In other words, you can think about the fact that the log base b and the log base b would cancel each other out. So you would be left with m equals n. And then you should check to see if any of your solutions are squares. So if we go to look at question 1, I notice that I have a log base 5 is equal to a log base 5. So if I use the rule that we just talked about up above, then I really just have the algebra problem 5x plus 9 is equal to 6x. We would subtract 5x from both sides. Go equals, and we would have 9 is equal to x. And if I wanted to check for extraneous solutions, then I would simply take the answer I got and plug it in and see if it works. And the answer I got was 9. So if we grab our calculator and we type in our calculator the question, and let me wait for my calculator here to get rolling. And I go to my calculator. And I type in the left-hand side of the question. The left-hand side of the equation is math. Actually, arrowing up is better. Log base, if I type in log base 5, and the problem was 5 times 9 plus 9. I get that. That's the left-hand side of the problem. And if I go math, log base 5, and the right-hand side of the problem was 6x, so 6 times 9. And hit enter, I should get the exact same thing, and I do. So the answer that worked, x equals 9. So x equals 9 is the answer. So check, it works. All right, if we move over here, we are going to notice that I have a log whose base is 2, and I have a log whose base is 2. That's fine. Then what I have is 1 minus 4m is equal to, I'm going to guess that's supposed to be an m plus 43. That's going to say that that's a typo there, my friends. We can't change variables in the middle of a problem. So then I would solve for m. So I would move these over, and I would move this over. And if I do that, I get negative 43. Those cancel, is equal to 6m. Oh, this was a 43. I don't know why I made it a 44. Sorry. So that makes this a negative 42, right? And then I would divide by 6, and I would divide by 6. So I have negative 7 is equal to m. So then if I go to plug it in, that is log whose base is 2, 1 minus 4 times negative 7 is equal to log whose base is 2, 2 times negative 7 plus 43. So if I type that into my calculator, go to my calculator, and go to math, then go up to log base 2, and the left-hand side was 1 minus 4 times negative 7. And I get that number, and then I go math, log 2, and 2 times negative 7 plus 43. And I get exactly the same thing, so my answer is correct. So negative 7 is the answer to the problem. Okay, so when I go over here and look at this, I notice that I have a log and a log and a log. That is different from the previous two because I only want the word log on the left and the word log on the right. I only want a logarithm equal to a logarithm. I do not want a couple logarithms. So here's what we're going to have to do then. In this case, we are going to have to combine these two logarithms so they are only one logarithm. And how are we going to do this? Well, this is a plus sign, and our rule is that plus means multiply. So what I really have is I have a logarithm of y plus 5 times 4 equals a logarithm 72. So this is a log of 4y plus 20 is equal to a log 72. If you're like, what? 4 times y, 4 times 5. Now that I have a logarithm on the left equal to a logarithm on the right, I can say that 4y plus 20 is equal to 72. Basic pre-algebra problem. So I'm going to move the 20, which will give me 4y's equal 52, and I'm going to divide by 4, which gives me y equals 13. So now that I have 13, I'm going to check it by putting it back in the original, which is log 13 plus 5 plus log 4 equals log 72. So on my calculator, I'm going to calculate the left-hand side of the problem. The left-hand side of the problem is log 13 plus 5 plus log 4, and I get some number. I don't care what the number is at all. All I care now is that the right-hand side is the same number. And it is, so it works. Yay! Whoopee! Woo! So that's the answer. So here, I do have a logarithm base 7 and a logarithm base 7, but I have this 3 in front. And the rules of condensing tell me that what I really have is this. In other words, the rule says that the coefficient is really the power. So that's what I made. So now that I have a logarithm base 7 and a logarithm base 7, I am going to say that 4 to the third power, that's 4 times 4 times 4, that's 64, is equal to 4a minus 8. So 72 is equal to 4a. So half of that's 36, half of that is 18, is a. And so then I need to check it. And the original problem was 3 log 7 4 equals log base 7, 4 times 18 minus 8. So I go to plug it in. If I go to plug it in, I have 3, I have math, I go up to log base 7, and in here I had the number 4. So that's the left-hand side of the equal sign. On the right-hand side of the equal sign, I have a log base 7, And then I have a 4 times 18 minus 8. And I really don't care what this number is, except it has to be the same. And it is, so my answer is correct. Yay! No extraneous solutions yet. I don't know if we have any on here or not. Okay, so again, this is the same rule as a moment ago. So I'm going to take this half power, and I'm going to make it the power of 25. So now I have log 6, 25 to the half power is equal to log base 6 of 23 minus 4w. So now that I have a logarithm base 6 and a logarithm base 6, I really just have the problem 25 to the half power equals 23 minus 4w. 25 to the half power equals 5. If you don't know that, 25 to the half power means the square root of 25. And the square root of 25 is 5. If you didn't know that, you could go to your calculator and you could type 25 raised to the power of 1/2 and hit enter and get the number 5. So a half power is the same as the square root. So that's a 5 equals, whoops, go black, equals 23 minus 4w. Moving the 25 over gets me negative, what, 15? No, negative 18 equals negative 4w. Did I subtract correct? 23 minus 5 is 18, yes. And divide by negative 4, I get 4.5 equals w. 18 divided by 4. 18 divided by 4, 4.5. What was the other number I wasn't really sure of? 5 minus 23. 5 minus 23. Sometimes your brain just doesn't want to believe that you are correct. So I'm correct on all fronts. My answer is 4.5. So if my answer is 4.5, I'm going to plug it in. And plugging it in, I have a half of log whose base 6 of 25 is equal to log base 6 of 23 minus 4 times 4.5. So let's type that into our calculator to see if it works. Okay, the left-hand side is a half. And then we have a logarithm whose base is 6. And inside that logarithm, we have a logarithm base 6 of 25. And we don't care what it equals, but it equals that. And then on the right-hand side of the equal sign, we go to math, base 6. And inside of that, we have 23 minus 4 times 4.5. And we hope for the same thing. We got the same thing, so our answer is correct. So our answer is 4.5. Alrighty, is that it on that? Nope, let's go over here. Over here I have many, many logarithms. I have a, why won't this change? Because it's not on. I have a logarithm base 3 on the left. I have a logarithm base 3 on the right, and another logarithm base 3 on the right. First thing I need to do is I need to make this a power. Second thing I need to remember is the rule for subtract means divide. So left-hand side's not changing. Log whose base is 3 of 2p minus 5. The right-hand side is log whose base is 3, 6 squared divided by 4. So now, I have a log base 3 on the left and a log base 3 on the right, so they are gone. So I have 2p minus 5 is equal to 9. 6 squared is 36. 36 divided by 4 is 9. So I have 2p is equal to 14, and I have p is equal to 7. So 7 might be the answer. 7 is the answer if it works. So we're going to go log base 3. 2 times 7 minus 5 is equal to 2 log base 3, 6 minus log base 3, 4. So let's plug it in and see. So the left-hand side of my equal sign says that I have a logarithm with a base of 3. And inside that logarithm, I have 2 times 7 minus 5. And all of that equals some strange thing. We don't care. Oh, it equals 2. Nice. Okay, so the right-hand side was 2. A logarithm whose base is 3. And then in here goes a 6. And then I have a minus. And another logarithm whose base is 3. And then I have a 4. And it should equal 2. And it does, so my answer is correct. So they equal each other, so 7 is the answer. All right, here we go. Oh, very nice. So I have a logarithm whose base is 4 and a logarithm whose base is 4. So I can just say m to the second is equal to 18 minus 7m. Oh, now I have created, I've gone from a logarithm to a quadratic. And the way we solve quadratics is we set them equal to 0 and we hope that they factor. So we set them equal to 0, so we have m squared plus 7m minus 18 is equal to 0. In case you didn't get that, we move the 18 over, we move the 7m over. Okay, now we look for factors of negative 18 that add to 7. So I'm going to say 9 minus 2. Multiplied, you get negative 18. Add, you get 7. So we have m plus 9 times n minus 2 is equal to 0. So one of my answers might be negative 9, and one of my answers might be 2. So I need to test this. And so what we have here is a log whose base is 4, and we have an m squared equaling a log whose base is 4, and we have an 18 minus 7m. And we're going to check negative 9, and we're going to check 2. So, the left-hand side of the problem. Left-hand side of the problem, we have a logarithm whose base is 4. And we would have our answer, which is a negative 9 squared. Notice the negative 9 needs to be put in a parenthesis, friends. If you don't, you will have the wrong answer. So the left-hand side equals 3 point something. The right-hand side is a logarithm whose base is 4. Whoops. Is a logarithm whose base is 4. And inside of that, we have 18 minus 7, minus 7 times our answer, which was negative 9. And hit enter. We get the same thing, so negative 9 works. Yes, 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 winner, winner, chicken dinner. Negative 9 works. So now let's go back and let's go see if the number 2 works. So here is the number 2. The number 2 gets us 1. And the number 2 gets us, should get us 1 again. Does it get us 1 again? It gets us 1 again, so they both work. Well, that wasn't very much fun. I thought we'd have an extraneous one there. Both of them work. This one works and this one works. Alrighty, here we go. Okay, a couple things. First of all, this is a plus, and addition in logarithms means multiply. So we are going to change this to log of 2k squared is equal to log of k squared plus 16. Now that this logarithm has been condensed and this logarithm is already condensed, we have 2k squared equals k squared plus 16. Again, we've created a quadratic because we have a second power. I would subtract k squared, and I would get k squared is equal to 16. I would take the square root of k squared, and I would get k is equal to a positive and a negative 4. So we have two answers. Check two answers. So that is log 2 plus log of k squared equals log of k squared plus 16. All right, so left-hand side of our problem. The left-hand side of our problem says a logarithm. No, it just says we have a logarithm. Yes. And in there we have 2. And then that is plus a logarithm of the number negative 4 and squared. So that's the left-hand side, and it equals that. The right-hand side would be 2 squared plus 16. And that equals something different. So, shoot, I should have used negative 4, my bad. I should have checked negative 4. I'm looking for 1.5051. So negative 4 works. And now I wonder if positive 4 works. So let's try positive 4. Positive 4 equals that. And, come on, positive 4 equals that. So positive and negative 4 both work as well. So both of those work. So positive and negative 4 will both work. All right, that is it, friends. Don't make it more challenging than it is. All right, have a great day.